Good morning. I'm going to attempt to do a screen cast of the solution of problem number 6 of problem set 5-5, which is to determine the acceleration of a bear sliding down the tree. The first thing we do is to sketch the situation, and in this particular case, when we're dealing with Newton's second law, we prepare something known as a free body diagram. It's a free body diagram. And what we have here is a picture of the bear, or a sketch of the bear, completely separated from his environment. It's as if he's floating in midair, and on that bear we superimpose the forces that are acting on the bear. So what are the forces that are acting on that bear? The first force we can think of, probably comes to mind, is the force of gravity. And that is acting downward, and that force we symbolize with the letter W, capital W, for the weight of the bear, which is equal to the mass of the bear times the acceleration of gravity, or 9.8 meters per second squared. We happen to know that the bear's mass is 100 kilograms. That's given in the problem statement. And of course, the acceleration of gravity, as I said, is 9.8 meters per second squared. We should all have that memorized by now. And it turns out, therefore, that the weight of the bear is 980 newtons. What other forces are acting on the bear? Well, there's a force of the tree, which is tending to slow the bear's rate of acceleration down, and we'll call that force F sub t, F standing for force, the subscript t standing for the force exerted by the tree. And we're given that that force is equal to, I think, 500 newtons, as I recall. Yes, 500 newtons from the problem statement. That's basically it for this particular bear. Everything's happening in the vertical direction. Nothing's going on horizontally, so we can apply Newton's second law to the vertical direction, which states that the sum of the forces in the y direction, which is the net force in the y direction, is equal to the mass of the bear times the acceleration in the y direction. So what is the sum of the forces in the y direction? Well, we have 500 newtons acting upwards. We have 980 newtons acting downward. That's the reason for the negative. So this is a positive acting upward, is equal to the mass of the bear, which is 100 kilograms, times the acceleration in the y direction. This turns out to be the net force, doing this algebraic addition or subtraction, as you will. This comes out to 480 newtons. It happens to be negative because the 980 is bigger than the 500, which is equal to 100 times the acceleration of the bear in the y direction. Solving for AY, we have that the acceleration is equal to minus 4.8 meters per second squared in the downward direction. That's what the negative symbolizes. So that basically answers the question, both for the net force of negative 480 newtons and the acceleration of the bear in the y direction, which is negative 4.8 meters per second squared. Certainly, if you have any questions about my solution here, send me a PT or a general discussion message, and I'll be sure to answer it. Thank you very much. We'll be talking to you soon.